This is a special report from About Space Today.
You know, how many of you remember taking a road trip with Mom and Dad? It was great fun, filled with anticipation, especially having to use a road map to get to our destination. Well, today, through space-age technology, we have navigation that we can hold right in the palm of our hands. We call it simply GPS. It stands for Global Positioning Satellite. In 2019, there were 28,596 GPS in orbit around the globe. But as NASA prepares to travel to the Moon, Mars, and into deep space, how will they determine where they are? Well, I'll have a special report from NASA on an atomic clock to guide our spacecraft. Next on About Space Today, are you ready to fly away on a dream vacation? For cruises and all-inclusive resort vacations, call D&D Cruise and Tours at 877-747-8631. That's 877-747-8631. And see us on Facebook, D&D Cruise and Tours, where your dreams become a reality. Welcome back. You might remember our interview with Atlanta astronomer Mark Banks when we discussed how Apollo astronauts used a sextant to check their position and distance from Earth. Well, all that may soon be changing. Here's a special report from NASA on using an atomic clock aboard our future spacecraft.
How do we navigate through space? Currently, spacecraft flying beyond Earth don't have a GPS to find their way through space. Navigators on Earth send a signal to the spacecraft, which receives it and sends it back. Extremely precise clocks on the ground, called atomic clocks, measure how long it takes the signal to make this two-way journey. The amount of time tells them how far away the spacecraft is and how fast it's going. The farther out in space the spacecraft is, the longer it takes to receive and send a signal. But what if humans are sent to another planet, like Mars? A two-way system that sends a signal from Earth to a spacecraft, back to Earth, and then to the spacecraft again, would take an average of 40 minutes. Imagine if the GPS on your phone took 40 minutes to calculate your position. You might miss your turn, or be several exits down the highway before it caught up with you. If humans travel to the Red Planet, it would be better if the system was one-way, allowing the explorers to immediately determine their current position, rather than waiting for that information to come back from Earth. NASA is testing new technology that would allow future explorers to do just that. The Deep Space Atomic Clock is the first demonstration of an atomic clock that can be used for navigation in deep space. It will allow a spacecraft to calculate its own trajectory instead of depending on Earth. If a spacecraft had one of these clocks on board, it could receive a signal from one of those big antennas on Earth and quickly measure its speed and position. The Deep Space Atomic Clock could one day let astronauts navigate safely and accurately to Mars and beyond. This technology demonstration is the first step in making one-way space navigation a reality.
That makes me think of how accurate are the clocks at home and the office. Another significant experiment will take place next year when the Artemis II crew launch to the Moon using laser communications. Space Coast News Editor Dawn Meyer has more on the story.
NASA is testing high-bandwidth laser or optical communications for the first time beyond the Moon, with a pioneering technology demonstration called the Deep Space Optical Communications, or DSOC. DSOC is attached to NASA's Psyche spacecraft, which launched in October of 2023, and will send and receive signals during the first 2 years of its 6-year journey to the metal-rich Psyche asteroid. The goal of DSOC is to demonstrate technology that can reliably transmit data at higher data speeds than other space communications technology like radio frequency systems. The project sent unique data sets of art and high-definition video along with engineering data from the Psyche spacecraft, transferring almost 11 terabits to and from the spacecraft. From Jet Propulsion Laboratory, Bill Klipstein, the DSOC project manager, and Abby Biswas, the DSOC project technologist, explain how DSOC works and its advantages.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate, and the application of that to deep space beyond the moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance, and Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA's committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Remember to invite your family and friends to listen to our podcast and follow us on Facebook at aboutspace.today. I'm David Denault.
This has been a special report from About Space Today.